Today, I'll be teaching about factor and remainder theorem. So let's start first with remainder theorem. Always remember that remainder theorem states that when a polynomial fx is divided by x minus a, the remainder is fa. Let's use this problem as an example. So the question here is what will be the remainder when fx is divided by x minus 3. The first thing that we will do is use the synthetic division. So get the divisor and reverse the sign of the constant. So it will be positive 3. Now, place this number inside the upside down divisor symbol. Bring down all the coefficients. 1, negative 3, 7, negative 1, and 5. Bring down 1. 1 times 3 is equals to 3. Negative 3 plus 3 it equals to 0. 0 times 3 it equals to 0. 7 plus 0 is equals to 7. 7 times 3 is equal to 21. Negative 1 plus 21 is equal to 20. 20 times 3 is equal to 60. And 60 plus 5 is equal to 65. The remainder of x raised to the fourth minus 3x cubed plus 7x squared minus x plus 5 divided by x minus 3 is 65. Now let's use another example. Again, get the divisor and reverse the sign of its constant, which is negative 3. Place it inside the upside down divisor symbol and place all the coefficient, which is 2, negative 3, negative 4, and 7, negative 17. Bring down 2. 2 times 3 is equal to 6. Negative 3 plus 6 equals to 3. 3 times 3 is equal to 9. Negative 4 plus 9 is equal to 5. 5 times 3 is equal to 15. Negative 17 plus 15 is equal to negative 2. So the remainder of 2x cubed minus 3x squared minus 4x minus 17 divided by x minus 3 is negative 2. Now let's go on with the factor theorem. In factor theorem, you must always remember that x minus r is a factor of polynomial px if and only if pr is equal to 0. Let's use this as an example. So the question is, will 2x cubed minus 6x squared minus 5x minus 12 divided by x minus 4 factorable or not? The first step is to get the divisor, which is x minus 4. Now, change the sign of its constant. So it will be positive 4. Now, change all the x to 4. So it will be p4 equals to 2 times 4 cubed minus 6 times 4 squared minus 5 times 4 minus 12. So 4 cubed is equal to 64 and 4 squared is equal to 16. 5 times 4 is equal to 20 and bring down minus 12. 2 times 64 is equal to 128 and 6 times 16 equals to 96. Bring down minus 20 and minus 12. Bring down 128 and negative 96 minus 20 minus 12 is equals to negative 128. So 128 minus 128 is equals to 0. Like what the theorem said, x minus r is a factor of polynomial px if and only if pr is 0. So the factor of 2x cubed minus 6x squared minus 5x minus 12 divided by x minus 4 is 0, which means it's factorable. Now, let's use this one as another example. Again, get the divisor, which is x plus 2, and reverse its constant. It will be negative 2. Now, change all the x to negative 2. So, it will be p times negative 2 is equals to negative 2 raised to the fourth minus negative 2 cubed minus 5 times negative 2 square plus negative 2 minus 2. So, negative 2 raised to the fourth is equals to 16. Negative times negative 2 cubed is equals to positive 8. Negative 5 times negative 2 square is equals to negative 20. Bring down negative 2 minus 2. 16 plus 8 is equals to 24. Negative 20 minus 2 is equals to negative 22. Bring down negative 2. 24 minus 22 is equals to 2. And bring down negative 2. So, 2 minus 2 is equals to 0. So, the factor of px equals to x raised to the fourth minus x cubed minus 5x plus x minus 2 is divided by x plus 2 is 0, which means it's factorable.
Quadratic inequalities. In solving quadratic inequalities, you will encounter equations that look like these. The difference between a quadratic equation and a quadratic inequality is that a quadratic equation uses an equal sign, but a quadratic inequality uses a less than, greater than, less than or equal to, and a greater than or equal to sign. Quadratic equations are used to find points, but in quadratic inequalities, we find intervals. Now let's move on to the first example. We have x squared plus 4 is greater than 0. The first thing we have to do is to factor the inequality. X squared plus 4 factored is x plus 2 times x plus 2 is greater than 0. Now that we have these factors, we need to find the points. And to do that, we are going to put these factors equal to 0. Now the next thing you have to do is to transpose positive 2 to the other side. So now we have x is equals to negative 2. Negative 2 is now your point. Okay. So as what you can see, I have already plotted negative 2. Now to find out whether it is included or not in the interval, we are going to use the factored inequality. Now, plug in negative 2 to x. You are going to end up with 0 times 0. And 0 greater than 0 is of course not true. So we are going to leave a hollow circle on top of negative 2. This means that a point is not included in the interval. Note that a shaded circle means that the point is included. A hollow circle means that it is not. So in our case, the circle is hollow. Now, let's try to plug in 0 to the factored inequality. Okay, so this will give us 4. Positive 4 is greater than 0, which is obviously true. And because of that, we are going to extend an arrow on the positive side. Okay, so now let's try something after negative 2. Now let's try to plug in negative 3 to x. This will give us negative 1 times negative 1, which is positive 1 is greater than 0. the statement is true. And because of this, I am going to extend an arrow to the negative side. Note that all points included in both arrows are included in the intervals, which means that our solution set will be negative infinity to negative 3 and negative 1 to positive infinity. In writing your solution set, you are going to use parentheses for infinities and for points that are not included. You are going to use a bracket if the point is included. So your solution set will look like this. Negative infinity to negative 3, comma, negative 1 to positive infinity. So now that is your solution set, and that is how you solve a quadratic inequality. Now let's move on to our next example. For our second example, we have x squared plus x minus 12 is less than 0. Our factors are x minus 4 and x plus 3. Now again, to find the points, we have to put these factors equal to 0. Transpose, and now we have x is equals 4 and x is equals to negative 3. These two will be our points. So now, I have already plotted the points. Now again, to find out whether these points are included in the interval or not, we have to try it with your factored inequality. So now we are going to test 4. I have already plugged in 4 to x. That will give us 4 minus 4 times 4 plus 3, which is 0. And 0 is less than 0 is a false statement. Because of that, I am going to leave a hollow circle on top of 4. Now let's try to plug in negative 3 to x. So here, we have negative 3 minus 4 times negative 3 plus 3 is less than 0. And again, it will give us 0 is less than 0, which is again a false statement. So I'm going to put a hollow circle on top of negative 3. Now let's test 0. Okay, so if we plug in 0, we'll have 0 minus 4 times 0 plus 3 is less than 0. Put a line in between negative 3 to 4. This means that all points in between negative 3 and 4 are included in the interval. So let's try 5 minus 4 times 5 plus 3. This will give us 1 times 8. And 8 is less than 0 will give us a false statement. Now let's try negative 4. So negative 4 minus 4 will give us negative 8. And negative 4 plus 3 will give us negative 1. Negative 8 times negative 1 will give us positive 8. It's less than 0, which is again a false statement. And because of that, I am not going to draw an arrow after negative 3. Your solution set will look like this. Negative 3 to positive 4. So that will be the end of it. Okay, a quick recap. Note that a shaded circle means that the point is included. A hollow circle means that it is not. In writing your solution set, you are only going to use parentheses for infinities and for points that are not included. You are going to use a bracket if the point is included. So that's how we solve a quadratic inequality, and I hope you learned something.